All right, to do this lesson, you need your unit circle. This will be a very helpful guide to use it. Also, if you don't like radians whatsoever, you can always convert these to degrees. I'm absolutely fine with it. I just use radians because of the book. I want to kind of stick with the book. Here, we're going to learn how to graph other kinds. So the basic one is what we graphed yesterday. In continuation with this, we have example 4. So we have r is equal to 2 plus 2 cosine theta. They said instead of doing the x and y, like that chart that we made, and it was very complicated and long, what you could do is graph it the normal way. Think of y equals 2 cosine plus 2. What I did, I moved the 2 to be second because that's how we saw it before, you know, like a sine b x minus h plus k. So that whole long equation when we were graphing, so that plus 2, you can always leave at the end. So it's not changing the sign, it's on the same side. So therefore I have at the end. So when I'm making this graph right here, so y equals 2 cosine theta plus 2. This is telling me it's my amplitude. So my minimum is 2, my maximum is negative 2. Cosine, remember you start with up, 0, down, 0, up. And then plus 2, meaning at every point that you're going to graph, you count 2 units upward. So here, so we're going to go ahead and graph this. So we know this is cosine, the period, there's no number in front of there, so we don't really do anything. We stick with the usual 90, 180, 270, 360, or whatever you have in radians in your chart. So we start with up 0, down 0. So normally you go up at your maximum, which is 2, but you always count 2 units upward because of the plus 2. So I have up here, 0, the next unit down is 0, but then I'm going to count 2 units up. Up 0, down, so from pi, or from radians, I'm going to count 2 down. But keep in mind, it's my minimum point is a negative 2, but I always have to count 2 up. So here, it's up 0, down, so that'll be a negative 2, but I need to count 2 units up. So that's why it's going to be right here. And this one's going to be 0, up 0, down 0, up. So 0 would be our next one here, but we would count 2 units upward from here. And then 2 radians will be up, which is up at your maximum, which is 2, but you have to count 2 units up. And then you have your graph like this. So from 0 to 2 radians, and that's what we're focusing on because that's what polar coordinates are. From 0 to 2 radians, I have 1, 2, 3, 4, 5. I have 5 different coordinates there. We're going to use those coordinates to help us graph our polar coordinates. So here, at this point here, we're not going to do x, y anymore. We're going to do radius, degrees. So our y is going to be considered our radius, and our x is going to be considered our degrees here. So here, our radius is considered 4, and the degree that it's in is 0, so 0 degrees. This next one here, our radians is 2, because it's at that level, the minimum maximum level, and the degree for that is radians over 2, or it's 90 degrees. And for this one, our radians is 0, but the degree is radians. And for this one here, I have the point as being 2 for my radius, and then at the measurement of 3 radians over 2. And this last one here, I'm at 4 and at 2 radians. So we're going to use each of these coordinates. It's not going to be 2 radians comma 4. We're not going to do it that method anymore because we're just focusing on radians. The radius and the degree. So now here, I'm going to put each of these points up here. So my radius of 4, my degree of 0, so just like this here. 2 radians over 2, make sure it's in order. 0, pi, I have 2, 3 radians over 2, and then my last one is 4, 2 radians. From these points, I'm going to go ahead and graph it here. 4, that means at my circle 4, 1, 2, 3, 4. At my circle 4, the degree is 0. Here is where the 0 mark is. You don't go up, you don't go down. So just going to stay here. My next one, at 2, we're going to have radians over 2, which is this line here. My mark for my radius is going to be 2, so I'll count 1, 2. There. 0. So at radians here, I don't move anywhere at all, so I just go back to the circle here. So my radius is 0, 1, 2, 3, 4, so I just stay at 0. 2 adds 3 radians over 2, so I'm going to count 1, 2. And then it's 4 at 2 radians here, so it goes back to here. And what it creates, you're not gonna make it perfect. It's gonna create some type of heart because it goes from here, 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 it stops here, and then it goes all the way around and goes around here. And it creates a cardioid. Think of like cardiac arrest. Cardiology is dealing with the heart. So it's a heart shaped. So for the pattern for that would be whenever you have like a +2, a -2, whenever you have that type of number, that changes into a cardioid shape. So then you have like a little heart here. Example 5 is where it gets a little bit more complicated because now this formula here, y equals cosine 2 theta, that 2 is now messing with the period. Normally from waves, it's the 90, 180, 270, 360. Super simple. But now here it's messing with the period. Remember, to find the period is 2 times radians divided by b. b is now considered our 2. So when I did that, to find my period, I have a period of radians. So that's 180 degrees. But keep in mind, we need a whole graph of 2 radians because we need to see the whole thing all together. So I did that. So I found my period, I divided into 4 parts so I can see the increments. And it's in radians over 4, radians over 2, through radians over 4, and then radians. And if I put it in decimal form, again, just put 180 divided by 4, 180 divided by 2. That will give you your degree form. And when you do that, it's in increments of 45 degrees. So it's 45, 90, 135, 180. So that means all I have is from here to there, but I have to keep on going until I hit 2 radians. So all I did, very simple. You can add 1/4 to radians and continue on, but we're not going to do that. This is 180, so we're going to add 45 to 180, you get 225. On my chart, I have 5 radians over 4. From 225, I'm going to add 45 degrees again. I get 270, which is 3 radians over 2. 270, add 45, I get 315. And in my chart, I have it as 7 radians over 4. Or you can add 1/4 to it. Both ways work. So now I have all my increments from 0 to 2 radians here. But my period, one wave, is from 0 to pi, but we have to create the whole wave from 0 to 2 radians. Now, period just tells us that the graph is just going to be a little bit smaller. It's going to be a little bit smushed. Here it just says cosine, so there's no amplitude, just from 1 and -1. Cosine, it's up 0, down 0, up 0, down 0. In this case, we don't have to, there's no +2 or -7, so we're not going up from that units like we did for the previous example. So here, from cosine, we're going to go up. From 45, we're going to go 0. 90, we're going to go down. 135, we're going to go back to 0. Radians, you're going to go up. And then you continue pattern. Up 0, down 0, up. So when we create the wave, we get a wave like that. When you graph it, and this is where it gets a little bit more complicated, it just has more points to deal with. Now we go ahead and write every point that we just did. So at 1, it was at 0 degrees. Here I went to 0 at radians over 4. Then here, down here, at -1, it hits radians over 2. Then back at 0, it's 3 radians over 4. Back up here, 1 at radians. This is one whole wave. But now we have to keep on going because we want until 2 radians. And plus I don't have any more room to bring it down. So then I keep on going. So I did this one. It's going to go back at 0 at 5 radians over 4. It hits -1 at 3 radians over 2. It hits 0 at 7 radians over 4. The last one, it hits 1 at 2 radians. Now, to graph all of this, the book has it where they kind of hit like a certain part of the wave and they graphed it. This way works the same way and it's a lot easier. Now let's go ahead and dot every point there. So looking at this, which I just created, remember it's increments of 45 degrees. So I started with 0, 45, 90, 135, 180, 225, 270, 315, and then 360. So you don't have to put more lines if you don't need to. This is just easier that way. Now let's go ahead and graph it. So here at 1, so I have a circle as 1 circle because it's a radius. The book has it, there's 4 circles. That means they divided 1 into 4 parts. So it's 1/4, 1/2, 3/4, and then the last line is considered 1. I graphed it like 5 different ways from 5 different sources, and they all gave me the same thing, just 1 circle. Meaning, the book just has a little different. Now, let's go ahead and graph it. So I'm going to stick with the 1 circle because the radius, the highest one is 1, lowest one is -1, so it's just 1. Let's go ahead and graph it. So 1, 0. So at 0 degrees, it's at 1, so that's right here. At radians over 4, it's at 0. I'm trying to make you see it. At radians over 2, it's at -1. Remember, if this is 1, -1 is hitting the opposite direction because it's radius. So it's going to be this dot right here. And then 0, so 3 radians over 4 is back at 0. And then 1, it's at radians here. And then it starts over here. So 0, 5 radians over 4, so back at 0. -1 adds 3 radians over 2. So 3 radians over 2 is here, so -1 would be the opposite direction, which would be right here. 0 at 7 radians over 4, so it goes back at 0. If you notice, it kept going back at 0 because it creates the circles here. And then 1 at 2 radians, which I have here. So when I do this, automatically from looking at the equation, you can tell it's a 4 clover leaf graph, but I just graphed it like. Oh, this is so ugly, but you get the point. It creates 4 petals from the center. So it creates a 4, the proper name is a 4-leaf rose. So it creates a graph that looks like that. The type of pattern that graph creates is 4-leaf rose. It's a rose. The pattern for that is R cosine AX, R cosine A, or sine AY. Sine AX. Meaning, if there is a number directly in front of the theta or in front of the x, this is going to signify that it's a 4-leaf rose. And again, I'll show you later how each number determines the number type of petals that it has. So example 4, if anything's adding or subtracting into it, you get this beautiful heart-shaped cardioid. If you have a number that's affecting your period, it is going to be a 4-leaf rose, and you have a shape that looks just like that. If you guys need any more help, make sure to let me know down there at the Dropbox. There's my email address. I miss you guys. Hope you guys have a good day.